All right, everybody. So at this stage, you've learned how to do analysis on your models, right? So I got you sort of up to the level where you can make structures that have intriguing facade components and all that other fancy, jazzy stuff. You can create perforations. You can create louvers that rotate and revolve. You can create patterns that have random reduces that look interesting or more intriguing or whatever. So think of this as like a finished product for a moment. Our analysis only goes so far, right? When we measured what the square footage was of the canopy system that we designed in our little courtyard, we were just measuring the square footage of the surfaces. But if you have a canopy surface that goes like this, okay, need some new markers. If you have a canopy surface that kind of leans down like this, and you're measuring the square footage of this thing, let's call it 100 square feet, and our sun angle is at something like, I don't know, 80. So let's call it up there, right? So you know that sun angles are always assumed to be straight when you're diagramming this. So if 80 degrees is down like this, and we're measuring down like that, and down like that, more or less, when that thing hits the surface, it's going to hit it at a slightly wider surface area than it actually is in its origin. Okay, so that's important. This is like x, and this is like x plus, 2 or whatever the case is, times 2 or something like that, depending on what the angle is. We're not doing algebra in this class. But that's a principle that we need to understand as a limitation for what we can achieve. But what's cool is we're learning how to do visual programming, which means we're literally programming things using algorithms, which also means we can do things that are a lot smarter than us because smarter programmers have programmed it for us. So that's really important to understand. So remember the metaphor I gave you before about somebody giving you the keys to a car and letting you drive it versus somebody teaching you how to build a car? Well, until now, we've been learning how to build a car. I don't need you to be able to build the entire car. I just need you to understand how it works so that when you're using it, you can kind of tweak it to your advantage. So let's do that. So we're going to move into the environmental analysis tools using Ladybug, which is pretty powerful. We're going to kind of spread that out through the remainder of the semester and kind of roll out certain features as we need them or as they become appropriate for what you're doing in design. But I'm going to give you the basics of it starting today. But we're also going to have to test that it works too. So Ladybug has a separate tab. It's right here, obviously called Ladybug. Ladybug is not just a set of tools. It's an engine that has to run. So in order to get the engine running, we have to drop this node into our workspace. So when we drop it in, it's going to take a little bit to compute, and hopefully it'll say a little buzz thing, and it should work for us. So I'm going to drop in a panel right now so you can see what it's reading. All right, so there you go. So when it's buzzing or when it's flying, that means that it's running. If it says something else and gives you like an error message that says it's not functioning or it's not flying, that means there's something wrong with the engine and probably the installation was configured incorrectly. So basically, this thing is the workhorse behind everything that Ladybug is doing. All the other tools that you see in the Ladybug menu are just tools that are processing off of that engine. Okay, so what I want to do with you right now is show you how to set up a sun path diagram around your building. So I'm going to go into top view. So here's my building. I find it kind of interesting because I put it on like a 3 degree or 2 degree off axis, just so you can see a little difference in something. But Ladybug is going to use the coordinate system that's set up in the model. So the x-axis going off to the right, that is due east. The y-axis going up is due north, and then west is that way and south is that way. Okay, so that's, I think, something that you're all well aware of thus far. So the tools here, and I always kind of have to re-find where they are. So I'm just going to type some in. So let's go to sun path, Ladybug sun path. So it is in, oh, oh, that's right, I forgot about this. So this brings you to the Python script node because this has been programmed in Python. So when you're using this little shortcut finder, it doesn't work. So that's fine because you kind of know what you need to use anyway. But judging by when I hover over this thing and I look at the icon, I can look up here and I can see that it's under visualized weather data and it's under Ladybug sun path. You guys are familiar with what a sun path is, correct?
Yes.
Raise your hand if you need a refresher. Nobody. Good. It's okay. It's okay if you do, though. Okay, so one thing that you need to understand is that it's going to ask you for a lot of information, and it has the power of pushing out a lot more information. What it's going to ask you for is the direction of north. Generally, it doesn't really need to be defined because north is north based off of the coordinate system unless you change it. We probably won't in this class. Then it's going to ask you for a location. And this is the most important thing about using Ladybug. Why is that?
Sun path. I mean, it's gonna depend on where you're at.
Right. It depends on where you are in the world. Okay. What do I want to say next? Okay. Anyway, so yes, it's incredibly important because where you are in the world has a profound impact on the environment, the environmental influence on your building and the environment within it. So how many of you have done any degree of environmental analysis with any software previous to now? Yeah, one person. None of you have used Ecotect or Sephira or anything like that? Really?
What?
I find that surprising. Okay, so when we're dealing with software and we're dealing with environment, the good thing is we have governmental agencies and private organizations that already measure environmental conditions around the world periodically at ridiculously, awesome intervals. So you can get it like down to the minute or down to the second, but generally that's too much information. So what we're looking at here in terms of time when we're looking at environmental analysis is it's going to be broken down into hours of the day, days of the year, and then months of the year. And then you can change the analysis period in slightly different ways. But anyway, what we need to do to define the location is input some of the data for the environment of a location that we're testing for. So let's say we're using, let's say our site is in Los Angeles, right? So we go to Energy Plus. Have any of you heard of Energy Plus before? No. Okay. I'm trying to gauge exactly how brand spanking new this is to each of you. And normally by now, usually like third year we've done some, or third semester we've done some of this stuff. But anyway, let's type in Los Angeles. And that's energyplus.net, by the way. So I don't know that it necessarily matters which one of these we use, but I tend to go with airport data wherever it's feasible. But it also depends on like where that particular weather station is relative to your site. Because you might have a site that's in the desert in the shadow of Mount San Jacinto, but then if you use the Mount San Jacinto weather station that's up in Idlewild, which is only a couple miles away laterally as the crow flies, that's going to be a completely different weather condition than if you use the one that's out in Palm Springs, which is a number of miles away but is more appropriate. Okay, that's just a sidebar that you guys need to understand in terms of climate. So let's use Los Angeles International Airport, and when you go back to this real quick and you read the description under location, it's going to say the output from the import EPW or construct location component. So EPW is a file type, environmental something weather, probably. I don't know what it stands for. I probably should know what it stands for, but it doesn't matter because it's right here. Here's the EPW file. Click it, and it should download. Down here, it's downloading. Okay, so
Ladybug needs this to run right.
it will, yes. Most of the functions you can manually create the stuff, but you don't need to. I'm going to go to class definitions and put resources. Put a resources folder in here. Resources. There it is. So it says it's an EPW file. It's right there. I'm going to copy this file location and go back into Grasshopper. So now I need to use the import EPW component in order to get this information into Grasshopper in a file format it can read. So again, import EPW. Looks like it's going to be, yeah, there it is. Oh, that's right. It's up here. It's right up here. So Ladybug import EPW. Boom. So this has, I mean, you can see some information that relates to this, particularly location, which is kind of like it. So let's figure out then how we're going to import that EPW file. We're going to also need the download EPW weather file. So it's these two right here. So the top one is download EPW file. And what's cool about Grasshopper is it has some default ways of drawing information from other files. So now we're getting into this like really high level way of getting information to flow through multiple software packages, because this information is being processed and then turned into an EPW CSV file. The CSV file is being read by Grasshopper. Grasshopper is going to produce something. You can export it into other CSV files or whatever you want to do, and then process it through like your ecotext system again back into your building energy analysis and put it in Revit, all this other kind of cool stuff. But in order to get this to speak to, in order to get the download EPW file to speak to the import EPW file, we need to give it a file location to read. So let's see. Oh, is it open actually? I forget which one it is. Weather file URL. We could do a URL or a directory. Oh well, let's do this. Let's go to params. Let's go to primitive. And we're going to do this one right here called file path. And I'm going to put a little title in this one. Params primitive file path. Just so you know exactly what it is. I'm going to call this LAX EPW. When you right click that, this is how we're going to insert the data. We're not linking geometry in Rhino in this case. We're actually going to set a file path. When I click that, it gives me my navigation. So I can do that, select the file, and hit open. Okay, so this shows, when you hover over it, it should show where you saved that file. And then we're going to plug that into download. Oh, look at that. From text to bool. Oh, maybe it's the other one I needed. Let me check that real quick. Ladybug, let's go to open EPW file. And let's try that. That didn't work either. Hang on a moment. EPW. Oh, I think this is for set Boolean to true. Oh, that's something else. Sorry. We actually don't need this. We could just plug this directly into the EPW file. So I walked you down a weird path, but okay. So when we plug this in, let's take a look at some of the rest of the information. So we already know that Ladybug is flying. We don't need to do anything with that. We just know that it is there and it's working. So we're going to go to params. We're going to go to panels, and let's take a look at that README. Hourly weather data for Los Angeles is imported successfully. I can look at the latitude, which is 33.93. Location gives me a lot of information about the location of where I'm testing my information for. And then here's what's really interesting. We get a long list, super long list, of a bunch of values for various points of environmental analysis. That will come into play for certain things, but what we're interested in right now is location. So we're going to plug location into location, and then zoom out. So this gives us our sun, our sun path diagram around our building, and we can actually change the sun path scale. Looks like the default is set to 1.0, so let's do a 0 to 1.00, and let's put that on sun path scale, and then we can scale it up relative to the size of our building. Now we can look at it a little bit more closely. You generally want it to be a fair degree larger than the building itself when you're looking at a sun path diagram, so you can more easily assume a straight line projection. Because right now the line is coming from the sun, which is right here, and it's going to the origin. Whoops, that's not really to the origin, but you get the idea. It just snapped to something. So it goes to the origin. It does not go to the center of the building. If you want to align it a little bit more closely, you can edit the center point, and you can go to param point, and we're going to say set 1 point, set that, and we're going to plug that into center point. And it's going to relocate that diagram so that now wherever the sun angle is, it's leading toward the center of my building. Okay. How many of you know how to read this diagram? Okay, we'll talk about that in a moment. What questions do you have so far? Yeah.
So Ladybug can be downloaded in the Rhino, the website?
Yeah, it's free. It's free. So yeah, the installation process is kind of funky, so you're going to have to very carefully read the installation instructions that come with it. Any other questions?